this video will cover sum and difference identities using the trigonometric functions that we have been dealing with for quite some time now. I'm not going to have you memorize this for the test or the quiz. You can definitely have it on your note card. On the final, they have this for you if you need it. So I'll let you pause this screen if you want to jot these down for your notes. We will be using all of them today. Okay, so I want to find exact values. The way that we found these exact values earlier in the last unit was I just typed it in my calculator and I was able to write down 3, 4 decimal places, whatever Mr. Lovelady wanted. Now we have a better way of doing it. All right, so to find the exact value here, what I'm going to do is I'm going to break apart this 105 into 2 nice angles that are on my unit circle. Now, you can use addition on it, you can use subtraction, doesn't matter. It's kind of big. I like to leave stuff in the first quadrant. So what I'm going to do is I'm going to rewrite the 105. I'm going to choose 45 and 60 degrees. Okay. I definitely could have used, what else could I have used? I could have used 135 minus 30 degrees. I assure you, no matter which two you choose, your answer might look a little bit different, but it'll be, you'll have the same numbers. They just might be rearranged. Okay. So going back real quick, I'm looking for my identity that has cosine. Oh, that was pretty cool. Didn't mean to do that, but I did. It's really cool. I'm looking for the one that has cosine of alpha plus beta. I just happened to put it right next door to it. Okay. And so in order to work this, it says I want to take cosine of alpha, cosine of, I say alpha and beta, A and B. So it just says take cosine of A times cosine of B minus sine of my A times sine of my B. Okay, so we've made it to here. Let me go back so all that writing's out of the way. And from here, these are just the basic trig functions that we have, that we've been having quizzes over. You've got to know these values. And so I just go through, pencil in these values. Square root of 2 over 2. Cosine of 60, I do believe is 1/2. Correct me if I'm wrong. Later, after the video. It's going to already be done. Kind of hard to do. I'm just going to do numerator times numerator, denominator times denominator. This answer's fine. I tend to write everything as a happy family over the same denominator. So not nearly as abstract as what we were doing with the identities on the board the last couple days. So that's good. That's good. Now, with radians, it's going to be a little bit trickier. Okay. Now, one thing that's going to be trickier about this is that I'm looking at it, and none of these special angles on my unit circle have a denominator of 12. That's okay. That's all right. I might just have to do a guess and check to find it. I've been doing this a while, so my guess is going to be really good. So I'm going to use 4 pi over 12 minus 3 pi over 12. I know good and well that gives me 1 pi over 12. That matches. How do I know those angles are good? I can actually simplify both of these to pi over 3 minus pi over 4, which is what is on my unit circle. So I'm going to let you finish this problem. You can go back and get the sine of A minus B this time. That formula, plug in your numbers, you'll be surprised. Your answer is going to look pretty similar to what we got down here. Okay, so go ahead and hit pause. I'll let you work that one. And I hope that one fared well for you. Square root of 6 minus square root of 2 over 4. On these sine and cosines, a lot of square root of 6 is a lot of square root of 2's. Okay, you'll see that. And the few that I assigned in the homework, so make sure you work those. Okay. I want to just tangent one together. It's not going to be hard from the trigonometric standpoint. It's going to be hard to get it cleaned up to what we want it to look like. Okay. I'd love to hear some guesses as to what you think, what 2 angles add up to give me this. I'll tell you, stay away from quadrant angles. Those do not work. Like like a pi over 2, pi. Those won't ever work with these. Again, otherwise we'd have a nice angle. So, oh, 3 and I'm just thinking 3 and 8. I know once I say it, it sounds easy. 3 plus 8 does equal 11. And sure enough, whenever I reduce this down, I get tangent of pi over 4 plus, let's see, that's 2/3. So 2 pi. And a little hint, just if you're watching this video, I don't know if I let this hint out in class or not, but man, if you use the pi over 3 as a tangent, you're going to shorten your work by just a smidge. Okay? So I'm going to go back to the last slide. I'm going to grab my tangent of A plus B. Okay. If you need to go back and look at it, go ahead. I'm going to hit a wrong button or something, so I'm just going to go ahead and try to roll with it. Tangent was kind of easy for me to remember because it's just tangent. It kind of just distributes here on top with a plus sign. And then on bottom, you just do 1 minus, or 1 the opposite sign of the 2 things that you put on top multiplied together. So yeah, this isn't going to be too bad because tangent pi over 4 is 1. Tangent 2 pi over 3, I've got to get that out of the second quadrant. So that's going to be a negative square root of 3. And then I have 1 minus 1 times negative square root of 3. And that's going to give me 1 minus the square root of 3 still on top. Now on the bottom, I got a negative and a negative right here. It's going to give me a positive. 1 plus the square root of 3. Like I said, the trigonometry for this is not going to be bad. What's going to be hard now is cleaning this up. Because hopefully when you saw this answer, you got a red flag right here. And a square root on bottom. According to Mr. Lovelady, that's a no-go. So I'm gonna come over here to the middle, finish working this out. So to clean this up, you remember the days of algebra 2 multiplied by the conjugate. That's going to cause some really unique stuff to happen. Okay. Now this will happen every time. But I'm going to go ahead and FOIL out the top and the bottom to show you what unique happens. Just to remind you, okay, it's probably been a while since you have done this. Okay. Negative and negative is a positive. Square root of 3 times square root of 3 is 3. Now, watch what happens on bottom whenever I FOIL this. 1 times 1, and then the outside is a negative square root of 3. The inside is a positive square root of 3. And then I get a positive and negative, so I get a minus 3 at the end. Remember, the good part about multiplying by conjugate is that your O and your I cancel. So cleaning up the top, I get 1 plus 3. That's usually 4. And on Tuesdays in the Zoom. And then 1 minus 3, I have a negative 2 on bottom. Well, now let's have a common denominator. Or you can think of it, I can take a negative 2 out of all 3 of these terms that are sitting right here. I always think of it, I just do 4 divided by negative 2 is negative 2. And then negative 2 divided by negative 2 is a positive 1. So 1 square root of 3. That was a lot of work, but I assure you a lot of your tangents will look very similar to this. All right, about 8 minutes in on this video, but I'm going to wait for your buddies to come in for the rest of the class, and we will finish it then. So I'm going to hit pause, and I'll see you guys in a bit. All right, everyone's in here now, so I'll go a little bit slower, all right, so that they can all keep up. And it's weird on this one, they didn't tell me what alpha and beta are. All right, so this is just going to be an angle. Now, it tells me about alpha and beta. I just don't know what their values are going to be. So I think a picture goes a long way on this. All right, so, okay, first of all, it says that alpha is between 0 and pi over 2. What quadrant do you think that is between 0 and pi over 2? Where's that at? It's the first quadrant. I thought it was a fire drill. So what I'm going to do is I'm going to draw myself an angle in the first quadrant and then make a reference triangle off of it. Reference triangles come down and they make a triangle with the x-axis. And so I'm calling this angle right here alpha. So I can get more information about this angle. Because right now, all I know is that sine alpha is 3/5. I'm willing to bet you can tell me two of these sides on alpha, on this alpha triangle. I hope. I think you know the opposite in the hypotenuse, don't you? It's an alpha. It's not a fish. I didn't close off the fin. Now, if those two sides of my right triangle are 3 and 5, does anybody want to go on a limb for this third side? 4. All I did, it tells me that sine alpha is 3/5, so I just went opposite of hypotenuse for 3/5. The old SOHCAHTOA. All right. Now, that's my alpha triangle. I'm going to make a beta triangle. Beta. Oh, I am not doing it right. So what quadrant is my beta going to be in? Third, how you know? All right, between pi and 3 pi over 2. Again, I'm going to make a reference triangle. Reference triangle has one of the legs as the x-axis. So my beta is always, my alpha, beta, whatever it is, it's always going to be this angle that's in here next to the origin. And what do I know about the sides of this beta triangle? -5 and 13. Which side is which? Opposite? This is adjacent and hypotenuse, correct? Adjacent and hypotenuse. So the adjacent side is 5. Wait, which one does the negative go with? 13? If it was both, it'd be positive because it'd be negative over negative. -5. The R cannot be positive. R stands for radius. Radius is a distance on my circle. Okay. Okay. So -5. So does anybody want to take a guess on what this other side is going to be? What are we guessing? 12. 12. I know. Does anybody have the right answer? 12, right? 5, 12, 13. I disagree. I think it's close. -12. Why is it negative, Madeline? It went down. It went down. No. Okay, so. Yes. Yes. All right, help me out here. Anybody have these memorized yet? Sine of alpha plus beta. Sine of A plus B. What do we got? Great. Okay. Now the only difference this time is that I don't have nice angles to plug into this. All right. I have my angles. This is the information I have about it, and I'm going to cheat a little bit. Can I cheat? It already. Oh, I'm so excited. Alpha, beta, alpha. Nope, it's alpha. All right, so I'm going to cheat a little bit. Any information they told me up here in the original, I'm going to go ahead and bring it down. So sine of alpha is 3/5. So bring it down. All right, cosine of beta, where's that at? Right here, -5/13. So bring it down. That's all I can cheat on this. So I'm going to come over here. I'm going to find cosine of alpha. I'm going to go to my alpha triangle right here on top. What is cosine of this alpha? How'd you get that? Yeah. Cosine of this alpha angle right here is still going to be just adjacent over hypotenuse. So I've just turned this problem that looks pretty tough into a SOHCAHTOA problem. So cosine is going to be 4/5. Okay, sine of beta. I'm going to come over here and get my beta triangle. I want sine of this beta. What are you thinking? Okay, it's opposite over hypotenuse, -12/13. You'll want to have a triangle. Because sine, remember the original definition was opposite over hypotenuse of this beta angle. Okay, so I'm just going to do numerator times numerator, denominator times denominator. So -15 over 5 times 13. $65, yeah, 65. Plus, so I got a -48 on top, and another 65. That's -15/65 plus -48/65. That'd be my answer. Thank you. Yeah, I like it better. All right. You and your pod buddies, you guys go attack cosine of alpha minus beta. Okay? And we're going to pause the video. You come back and see if you match what these guys get in here. So -56/65. Okay, keep in mind it is sine and cosine. So whenever I do work this out, all my answers should be between 1 and -1. Remember, it oscillates between 1 and -1, the graph of it. So that's kind of a way you can check it and know that -96/65 does not work. So I'll take a look at that in a minute. All right, one more I want to, or two more I guess I want to talk about. Kind of a mixture of the two, variable and this. Now we just did cosine of A plus B, right? So I'm sorry I'm going back and forth between alpha and beta and A and B. I'm just trying to use both so that later on when we see it, you'll be used to both. So I'm just going to go ahead and write down my formula, which will hopefully be in the margin or at the top of my page. On your homework, you can definitely have it in the top margin homework for the quiz tomorrow. Now, these aren't going to be that bad. These aren't going to clean up a lot, but I like them because we're getting into some of our values. Okay, so cosine of A is simply just going to be cosine of X. I'm just plugging in. I'm just going to plug in my A and B like I did on Friday with the notes. Okay, B, what's in the B position? 11 pi over 6. And then sine of A, sine of X, and then sine of B would be sine of 11 pi over 6. That's a pi over 6. So 11 pi over 6. There we go. From here, I just have two values to plug in, and I'll see if I have a GCF or anything to combine. So cosine of X, there's nothing I can really do with that. So what's cosine of 11 pi over 6? That's great. Are we getting rusty on this? All right, put everything away. Get out a sheet of notebook paper, clean sheet of notebook paper. All right, so cosine of 11 pi over 6. I've been something that would have been up there. So we got cosine pi over 6. Square root of 3 over 2. What quadrant are we in? We're in the cash quadrant. So this is just going to be square root of 3 over 2 cosine x. Okay, can't do anything with that cosine x. So I'm going to wait and see if I need this negative right here. Sine of 11 pi over 6. Okay, value is 1/2, positive or negative? It's negative. So I got a negative and negative is going to be a positive. 1/2 sine x. That's as far as that goes. Okay, we'll be doing something a little bit more with this maybe at the end of next week. All right. Because this was negative 1/2. So negative and a negative will be a positive. Or you can put minus negative 1/2 sine x. That'd be fine as well. Okay. Yeah, match that. That was a fluke. All right, let's try this. Okay, everybody go find your cosecant sum or difference identity. We don't have one, right? We don't have one.
Yeah.
So you use the sine one, but just flip it? I agree. Okay, let's try it. Let's just try the sine one. Okay, I'm just going to plug it in. I can't flip those numbers inside because 2 over pi doesn't really make sense. Yeah, we'll get there. So I'm just going to write down my equation again. Check me on this. I tend to make stuff up every now and then, like verifying trig identities. That really wasn't a thing. Let's plug in our values on this. Okay, so sine of pi over 2 cosine of t minus cosine of pi over 2 sine of t. Interesting. Now, sine of pi over 2. See, that's the, oh, it's not up there. 1. Okay, 1 times cosine t. Interesting. Minus cosine pi over 2. 0. Times sine of t. 0, so minus 0. What's cosine of t minus 0? There you go. That's your answer.
Your answer is called.
No.
Wait, no. It would be 1 over cos.
Ah, remember we're going to do the whole reciprocal thing.
Don't you try.
We're going to do the whole reciprocal thing. So it doesn't equal it, but let's pull this out right here. Let's go back and erase this sign. Remember, I'm wanting the reciprocal of it. So it'd just be the reciprocal of what I got with sine. So 1 over cosine, which is secant. My answer is secant t. That was fun.
I don't like your parts.
Nah, this and be this one. It is an identity. It's called a cofunction identity. So you know how this one's cosecant and this one's secant? I could do the same thing. If I did this to be sine, this would turn out to be cosine. If I change this to tangent, this would turn out to be cotangent. They're called cofunction identities, and they only differ by 90 degrees. Beautiful. It is. It is. All right. There is your homework. There's your practice problems.